We finish this section by taking a look at example number 5. And we're going to take a look at the polynomial f of x is equal to 2x to the fourth minus 2x cubed minus 60x squared. And we're going to graph it by using these 6 different steps that we see here. So the first thing that I'm going to do is I'm going to take a look at part A, which says the following. It says identify the degree and the leading coefficient. But remember, when we identified the degree of the polynomial and the leading coefficient, that's going to give us an idea as to what the end behavior of the graph looks like. So it's in unfactored form, so that means we just look for the highest exponent. So this is a 4th degree polynomial. And we have a leading coefficient of 2, which means it's positive. So we have an even degree, positive leading coefficient. The end behavior is going to look a little something like this. One arm's going to go up and the other arm's going to go up as well. So we know what the end behavior is going to look like. Let's move on to part B to help us find all the real zeros. Now, when we're finding the real zeros of a polynomial, so for the real zeros of this, that means we want to let f of x, so for part B, we'll do that down here, we want to let f of x equal 0. So we're going to solve this equation, 2x to the fourth minus 2x cubed minus 60x squared. And we're going to solve that by factoring it as completely as possible. So taking a look over here, we have a GCF of 2x squared. We're going to factor 2x squared out of this. We're left with x squared minus x minus 30. Factoring it even further, we need two numbers whose product is negative 30. That sums to negative 1. And those two numbers are going to be negative 6 and positive 5. So we're on our way to finding all the real zeros. Now we're going to set each one of these linear factors. So each one of these linear factors, we're going to set them equal to 0 and solve. Oops, sorry about that. Set each one of these equal to 0 and solve. So let's take a look at the first one. We have 0 is equal to 2x squared. We're going to divide both sides by 2. And that gives us 0 is equal to x squared. Take plus or minus the square root of both sides. We get plus or minus the square root of 0 is equal to x, which means that x is equal to 0. Now keep in mind, this 2 over here tells us that we have a 0 of multiplicity 2. So we're going to talk more about that in sections to come. But for one solution here, we have x equals 0 with multiplicity 2. Let's see, now we're going to solve these other equations. Let's go back to 0 is equal to x minus 6. To get x by itself, we're going to add 6 to each side. And that's just occurring once. So x equals 6 is a solution of multiplicity 1. And then the last one that we want to solve is this guy over here, x plus 5. 0 is equal to x plus 5. Subtract 5 from each side, and we have another one at x is equal to negative 5. Same thing, it's a first degree, so we have multiplicity 1. Okay, so we took care of part B. Find all of the real zeros of f of x. Now remember that the real zeros are the same thing as saying the x-intercept. So I'm going to start sketching this. We'll sketch this over here on part B. And what this tells us so far is that we have 3 x-intercepts. We have an x-intercept at 0. We have an x-intercept at 6. Here, we have an x-intercept at negative 5. Okay, so 3 x-intercepts. The next thing that we want to do, we took care of part A, we took care of part B. We want to find the y-intercept. So to find the y-intercept, we're going to substitute 0 in for x. So I'm going to go back to my original equation and put in a 0 every time I see an x, and it's going to look like this. F of 0 is going to be 2 times 0 to the fourth power minus 2 times 0 to the third power minus 60 times 0 squared. Okay, and notice this is just going to give us 0. And we already knew that. Once we have an x-intercept at the origin, which we had over there, we know we're going to have a y-intercept at the origin too. So we have a y-intercept at 0, 0, 0. Okay, let's take a look at part D, plot points between the x-intercepts. Right? So we have we have to plot points between these two intercepts over here. We have to plot points between 0 and 6, and we have to plot points between 0 and -5. I'm going to start off on the left-hand side, plotting points between 0 and -5. And again, you choose whatever number you're most comfortable choosing. I'm going to choose just -1 because it's going to make my life easier. And we get 2 times -1 to the 4th power minus 2 times -1 cubed minus 60 times -1. So this is going to, times -1 squared. So this is going to give us 2 times 1 minus 2 times -1 minus 60 times 1. And that's going to give us 2 plus 2 minus 60. That's the same thing as saying 4 minus 60, and that's the same thing as saying -56. So what that's telling us is the ordered pair -1, -56 goes through this. So this, and you don't have to write -56 hashes or 56 hashes. I'm just going to do this, -56. So -1, -56 is right around here. And then we're also going to test a point between 0 and +6. And again, I'm just going to let this one equal 1. So f of 1 is equal to 2 times 1 to the 4th minus 2 times 1 cubed minus 60 times 1 squared. We get 2 times 1 minus 2 times 1 minus 60. So let's see, we get 2 minus 60, and that gives us -60. So that's telling us the ordered pair 1, -60 is on the graph. Let's go over here. So 1, and we're going to go a little bit lower. Here's the ordered pair 1, -60. So we'll put -60 on this side. 1 for the x, -60 for the y. Let's see what else we need here. Well, for part E, so we plotted points between. For part E, we said identify the maximum number of turning points. Now remember, the maximum number of turning points is going to be 1 less than the degree of the polynomial. This is a 4th degree polynomial, and 4 minus 1 gives us 3. So we know that there's going to be 3 turning points. And for F, draw a continuous curve through all points you found on the graph. Okay, so the first thing I'm going to do is remember that this polynomial is a 4th degree polynomial with positive leading coefficient. So I'm going to draw the 2 arms up out of the outermost x-intercepts, and they were at 6 and -5. Now what we need to do is we need to connect the graphs in a smooth connected function. So we're going to go down here. We're going to come here. We're going to go back up. We're going to hit that 0, come down, and then head back up again. Now these guys, here's our 3 turning points that we talked about before. We have 1 turning point here, 1 turning point here, and 1 turning point here. We're not sure what those turning points are, but we're going to use calculus. So when we get to calculus, you're going to talk about how to find those turning points. But this is a good representation of the sketch of this function.